In this lesson, we're going to look at binary operations. So what's binary? What are binary operations? A binary operation is any rule of combination of any two elements of a given known empty set. A binary operation is any rule of combination of any two elements of a given known empty set. A binary operation is usually denoted by an asterisk, or sometimes we call it star with a symbol. And the most familiar examples of binary operations are those of addition, plus, subtraction, minus, multiplication, and division of real numbers. Binary operations use many other symbols apart from the asterisk or star symbol, apart from the symbol, to indicate operations or rule of combinations between two elements of a known empty set. Some of these symbols are, we can't give them names, so just look at them. You are going to see most of them as quick examples. These are some of the symbols used in, used for binary operations. Usually, when they are given, they will be defined. For instance, it may not really be plus or minus, could be a combination of addition, subtraction, division, or any of them. So we can say A star B is equal to 2x minus 3y. So in this case, you have multiplication and subtraction operations together. It can be if a box B is equal to can be a over b plus 3ab. It can just be anything. So this is the rule of combination of this binary operation. And in this case, a star b is equal to 2x minus 3y. This is the rule. This is what, so it means that any value that a takes, any value that b takes, how they are combined to form a third element belonging to the particular set that this operation should be carried out on. This is going to be the rule to be used for the combination. So examples will show clearly what this, how to go about this. So the binary operation, or the operation star on the set R of real numbers, is defined by x star y equal to 3x plus 2y minus 1. So in this case, this is the rule of combination between these two elements of the set R. So x, y can be any number, that's what it implies. So we need these two to represent any number that can be taken from the set R. First thing we do is to write down the rule of combination, which is x star y equals to 3x plus 2y minus 1. So remember that from the definition, say a binary operation is the rule of combination between two elements of a given known empty set. The binary operation usually involves two numbers, or a rule of combination between two numbers at a time. It cannot be more than two numbers. So these x, y, they are constants, or they are variables representing any value that is a member of the set R. So like in A tells us that 2 star 3. So these are two members of set R that are combined using this operation. B 4 star 5. So 4 and 5 are two numbers that belong to the set R that are combined using this operation. That's what it implies. C 1 over 3 star 1 over 2. These are also members of set R. 3 minus 1 are also members of set R that are combined using this operation to determine their value using this rule of combination. We can also say that this is the formula to be used. So let's proceed. 2 star 3. So what it implies is that from our rule of combination, x star y, and here 2 star 3, 2 is representing x and 3 is representing y, or in this case, x is equal to 2, y is equal to 3. So anywhere there is x in this on the right hand side of this equation, x, you put 2 in place of x, and you put 3 in place of y, and then you solve from there. You solve as you should. So 3 times 2 plus 2 times 3 minus 1. 3 times 2 is 6 plus 3 times 2 6 minus 1. 6 plus 6 is 12 minus 1, and this is equal to 11. So the value for 2 star 3 is 11. B is 4 star 5. 3 times 4. 3 star 4 plus 2 times 5 minus 1. 3 times 4 is 12 plus 10 minus 1. 12 plus 10 is 22 minus 1, which is 22 minus 1 is equal to 21. C. 1 over 3 star 1 over 2. 3 times 1 over 3 plus 2 times 1 over 2 minus 1. 2 here, 1, 2 here, 1, 2 here, 1, 2 here, 1. So 1 plus 1. 1 times 1 is 1 divided by 1, 1. 1 times 1 is 1. 1 divided by 1 is 1. Minus 1, so your answer is 1. Or we just say 2. So 1 plus 1 is 2 minus 1 is equal to 1. D. 3 star minus 1 is equal to 3 times 3 plus 2 minus 1 minus 1. 3 times 3 is 9 plus 2 times minus 1 is minus 1 minus 1. So 9 plus 1 times minus 1 minus 1 minus 1. This is equal to 9 minus 2, and this is equal to 7. Number 2. A binary operation star is defined on R. Number 2. A binary operation star is defined on R, a set of real numbers by x star y. X star y is equal to root xy. Root xy. For x and y members of set R. So if x star 2 star 8, x star 2 star is equal to 6, find x. So these are rule of combination, and then we have this part to simplify. We have to look for the value of x. So first time we use the value to star 8, because binary operation usually involves a rule of combination between two elements of a non-given of a known empty set at a time. So it's just two elements at a time. So we cannot carry out the operation on these three elements x2 and 8 at the same time. So we must work with 2 at the same time. So where in a case like this, we usually starts off with a bracket. So we're going to carry out the rule of combination on this bracket first. So 2 star 8. So let me say first evaluate plus evaluate 2 star 8. So 2 star 8. So x is 2 and y is 8 is equal to root 2 times 8, which is equal to root 16. So 2 star 8 is equal to 4. Okay, so we are getting the value of 2 star 8 on the same. Next, evaluate x star x star 2 star 8. So after we are getting this value for 2 star 8, I'm going to treat this as a single unit. So the whole of this bracket is y from our rule combination. Then x is x here. So now remember that the whole of this unit is 4. The value there is 4. So it's going to be x star 4. But so x star 2 star 8 is equal to x star 4. So you understand that this 4 is the value for 2 star 8, and 2 star 8 is taking the place of y here. So now we're going to get, and the question says that x star 2 star is equal to 6. So therefore, x star 4 equal to 6. And what's our rule of combination here? So when you say x 6 is equal, remember x star 4 is equal to 6. So our x roots, when you have x, and then plus x times 4. So that will give us 4x. So 6 is equal to root 4x. So what are we going to do? We're going to take square both sides. In order to eliminate the square root sign, we're going to square both sides. Square both sides. So we're going to have 6 squared is equal to root 4x squared. So 2 eliminate square root sign. So this will give us 36 equal to 4x. And to get the value of x, we need to divide both sides by 4. So say divide both sides by 4. And now we're going to have 4x over 4 equal to 36 over 4. So 4 here 1, 4 here 1, 4 here 1, 4 here 9. Therefore, x is equal to 9. A binary operation star is defined on the set R of real numbers by A star B. A star B is equal to AB over 4. Find the value of root 2 star root 6. Root 2 star root 6. So, as you well know already, root 2 is the value for A and root 6 is the value for B. So, in this equation, our A will be root 2 and B will be root 6. So, this will give us root 2 times root 6 over 4. So root 2 times root 6 is root 2 times 6 over 4, which equals to root 12 over 4. So that's our answer. The operation star on set Q of rational numbers is defined by P star Q equals to P raised to the power 2 plus Q minus 3PQ over 2. So where P, Q are members of set Q, determine A2 star 1. So 2 squared plus 1 times 3, 2 times 1 over 4. So 2 is power 2 is 4 plus 1 minus 3 times 2 is 6, 6 times 1 6 over 2. So 4 plus 1 5, 5 minus 6 minus 1 minus 1 over 2. The 3 star minus 1. From our rule of combination, our P is 3 plus 3 squared plus Q is minus 1 minus 3 times 3 times minus 1 over 2. 3 raised to the power 2 is 9 minus plus 1 times minus 1 is 9. So 3 times minus 3 times 3 is minus 9. Minus 9 times minus 1 is plus 9 over 2. So 9 minus 1 is 8. 8 plus 9 is 17 over 2. We can reduce this. Reduce so that will give us 8 over 1 over 2. C. Minus 4 star 5. Minus 4 star 5. Our formula P is minus 5 minus 4 is power 2 plus 5 minus 3 minus 4 5 over 2. So minus 4 raised to the power 2 is 16. 16 plus 5 minus 3 times minus 4 minus 12. Minus 12 times 5 gives us minus 3 times minus 4 is plus 12. Plus 12 times 5 is plus 60 over 2. So 16 plus 5 is 21. 21 plus 60, 81. 81 over 2. 81 divided by 2 will give us, to reduce it, that is 240 over 1 over 2. 40 over 1 over 2. D. 1 over 2 star. 1 over 2 star. 4 over 3. From our formula, P is 1 over 2, Q is 4 over 3. 1 over 2 squared plus 4 over 3 minus 3, 1 over 2, 4 over 3 minus 2. So 1 over 2 squared is 1 over 4 plus 4 over 3 minus 3 times, okay, 1 over 2 times 4 over 3, 1 times 4, multiplication of fraction, numerator multiplies numerator, denominator multiplies denominator. But before you do that, if anything can go like this, you do that, you reduce it to 2 into 2 into 4, 2. 1 times 2 is 2, 1 times 2 is 2, that's 2 over 2, multiplied by 2 minus 2 over 2 over 3. So this 2 will cancel this 2. You are left with minus 2. So this part is minus 2. Here is minus 2. You can say negative over 1. Because minus 2 is same thing as minus 2 over 1. So now we have a fraction. The LCM of the fraction is 12. 12 into 4 is 3. 3 times 1. 3. 12 into 3 is 4. 4 times 4. 16 minus 12 into 1. So 1 times 2. 12 into 1 is 12. 12 times 2 is 24. So 3 plus 16 is 19. 19 minus 24 is minus 5 over 12. Okay, minus 5 over 12. That's the answer. Number 2. A binary operation star on a set of real numbers is defined by A star B. A star B is equal to A plus B. A plus B minus 2. A plus B minus 2. So I so the figure 1 says 2 star 3. 2 star 3. Look for the value 2 star 3. So our rule of combination A plus B minus 3, A star B. A is 2 and B is 3 in this case. So we say 2 plus 3 minus 3. 2 plus 3 is equal to 5 minus 3, and that's equal to 2. Number figure 2. Let's look for 1 star 2. 1 star 2 star 3. And we need to look for the value of 1 star 2 first. If we compare this to general formula, A would be this whole part, this bracket enclosed. So this 1 star 2 we take it as a single variable, which is A, then star 3, which is B. But we need to first of all get the value of 1 star 2. So when you say 1 star 2 is equal to A, so we get the value of A here since B is already 3. So A is equal to 1 star 2 is equal to, using this formula, 1 plus 2 minus 3. 1 plus 2 is 3 minus 3, which is equal to 0. So therefore A is equal to 0 in this case. Yeah, so we can say 1 star 2, since 1 star 2 star 3 is equal to, okay, so therefore say 1 star 2 is equal to 0 star 3. So we're going to see therefore 0 star 3 equals to the formula E is 0 and 3 is B, 0 plus 3 minus 3, and that's also 3 minus 3, which is also equal to 0. So my figure 3. My figure 3 says 4 star 3 star 2. So comparing this with the general rule of combination, A is 4, 3 star 2 is B. So first thing is that we need to solve for 3 star 2 as a single unit. So let us say B 3 star 2 is equal to B, which is this part. So we need to get the value equal to E to be 4. So let's solve for this first. So B is equal to 3 star 2, which is equal to, from our general rule, B is 3 plus 2 minus 3, that's equal to 5 minus 2, which is equal to 2. So B is 2. So 4 star 2, that's what's going to imply. 4 star 3 star 2 will reduce. So here 3 star 2 is B. So this so 3 star 2 to 2. Therefore 4 star 3 star 2 is now equal to 4 star 2. So 4 star 2 is equal to, using the general formula, 4 plus 2 minus 3. 4 plus 2 is 6 minus 3, and this is equal to 3. Number 3. If A over B operation C over D is equal to A plus C over B D, evaluate I 2 over 3 operation minus 3 over 5. So we've been given the rule of combination here, which is about the formula. There is a rule of combination of these two elements of a given set. Okay, so now our A here is 2 over 3. Our A is rather 2 and C is minus 3. And B from here, B is 3 and B is 5. So A plus C has 2 plus minus 3, which is C, and then B here, which is 3 over 3 times 5, 3 times 5. Okay, so this will give us 2 plus 1 times minus 3 will give us 2 minus 3. 3 times 5 is 15, and this is minus 1 over 15. Number figure 2. Let's look for 1 over 3 operation 1 over 5 operation 2 over 2. So for us to this bracket here from our general operation is rule of what we have here. So let me say let's C over D equal to 1 over 5 operation 2 over 3. So once we carry out this operation, we are going to get the value for C and D, and then we can we can get the value for 1 over 3 operation, the value for C and D, which we are going to get after we've carried out this final operation. So C and D is equal to 1 here from our formula. E is 1, that's 1 plus, and our C is 2, 1 plus 2, then D 5 times 3, that's 3 over 15. 3 over 1, 3 over 5, that's 1 over 5. So C over D, therefore C over D is 1 over 5. Now, we're going to come back here. So let me say 1 over 3 operation. Okay, so 1 over 5 operation 2 over 3 is equals to 1 over 3 operation 1 over 5. So now we have the binary operation of A over B, operation C over D. So where 1 over 3 represents 1 over 5 is A over B and C over D. So now let's carry on this equation. So 1 over 3 operation 1 over 5 is equal to A is 1, C is 1, B is 3, and 5. So 1 plus 1 is 2 over 15. That's the answer. So if star n is equal to n minus n over n, where n is not equal to 0, because if n is equal to 0, that means whatever happens on the numerator side divided by 0 will make this part of the equation to be undefined. So n must not be equal to 0. So evaluate 3 star 5 star 2. So here our n is 3, n is 5 star, so you cannot have 3 operation 3 elements to be carried to be under the operation at the same time. So we're going to simplify this part. So the n is equal to 5 star 2, which is equal to here 5 is n, 5 minus 2 over 2, that's 2 over 2. So n is 3 over 2 over 2 star 5 star 2 is equal to 2 star 3 over 2. So we can also make it an over 1. Right now, so 3 therefore 3 over 1 star 3 over 2 is equal to 3 over 1 minus 3 over 2 over 3 over 2. So we can write it like this: 3 over 1 minus 3 over 2 divided by 3 over 2. So our LCM here is 2. 3 to 1 is 2, 2 times 2 is 6, 2 to 2 is 1, 1 times 3 divided by 3 over 2. 6 minus 2 is 3 over 2 divided by 3 over 2. Now this is division of fractions, so what we're going to do is to change division sign to multiplication, then we reciprocate with the 2 will come up, 3 will go down, so 2 over 3. 2 here 1, 2 here 1, 2 here 1, 2 here 1. So 1 times 1 is 1, 1 times 1 is 1. 1 divided by 1 is equal to 1. Now this is another one. Number 2. A binary operation is defined on a set of real numbers by P is equals to P minus Q, 2P minus Q minus 1 over P plus 1 over Q. So let's look for, now evaluate 1 over 2 minus 1 over 4 minus 1 over 4. So in this case, since the operation is between 2 elements only, we can proceed gradually. So P is 1 over 2, Q is minus 1 over 4. So put it into the equation, we're going to have 2 1 over 2 minus 1 over 4 minus 1 over 1 over 2 plus 1 over plus minus 1 over 1 over 4. Alright. Okay, so let's go. So this will give us 2 minus is plus 1 over 2 plus 1 over 4 minus. Now, when you have 1 over 1 over 2, it's just so it's like 1 divided by 1 over 2. This will give us 1 times 2 over 1. That will give us 2 times 1, 2 divided by 1 is equal to 2. So here will be 2 and plus times minus is minus. Same thing with what we have, the 1 divided by 1 over 4, which is 1 times 4 over 1. That will give us 4, 2 minus 4. So yeah, let's get the LCM, which is the LCM of this two. In fact, LCM of these two denominators is 4. 4 into 2 is 2, 2 times 1 2, plus 4 into 4 1, 1 times 1 is 1. That's equals 3 over 4. So 2 3 over 4 minus 2 minus 4 is minus 2. Minus 1 times minus 2. Replace minus 2. So now either you multiply the numerator by 2, or you can divide. So 2 times 2 is 6. So that will give us 6 over 4. 2 here, 2 here. So that will 0 over 2. Or we should simply divide from here. 2 here 1, 2 here 2. So that will give us 3 over 2. Same thing. Minus times minus 1 times minus 2 plus 2. Then 0 over 1. So let's simplify this part. LCM of 2 and 1 is 2. 2 into 2, 1. 1 times 3, 3 plus 2 into 1 is 2. 2 times 2 is 4. Times 3 plus 4, 7 over 2. And that will give us, when you reduce it to real number, 1 over 2. A binary operation is defined on the set R of real numbers by A operation B is equal to A squared minus 2AB plus B squared. So find 2 over 3 operation 3 over 4 from the rule of combination given to us. A is 2 over 3, B is 3 over 4. So 2 over 3 squared minus 2, 2 over 3 times 3 over 4 plus 3 over 4 squared. So 2 over 3, 2 raised to the power 2 is 4, 2 raised to the power 2 is 9, minus 2 here 1, 2 here 2, 3, 1, 1. So that's 2, 1 over 2 plus 2 raised to the power 2 is 9, 4 raised to the power 4 is 4 raised to the power 2 is 16. So 2 here 1, 2 here 1, 1 times 1, so that gives 4 over 9 minus 1 plus 9 over 16. Now 1 is equal to 1 over 1. So we can make it over 1. Now we need to look for the LCM of 9, 1 over 16. So if you do that, you're going to get 144. So 144 divided by 9 is 16. 16 times 4 will give us 64. 144 divided by 1 is 144. 144 times 1 equals 144 plus 144 divided by 16 is 9. 9 times 9 is 81. So if you add 64 plus 81, you're going to have 145. 145 minus 144 will give us 1 over 144. That's your answer. So I says find R such that 2 operation minus 5 is equal to R. So the first thing is to look for this part. Let's let's write the equation 2 operation minus 5 is equal to R. Our first step is to evaluate 2 operation minus 5. So first evaluate 2 operation minus 5. So 2 operation minus 5. Our formula gives us 2 squared minus 2 times 2 times 5 times minus 5 times minus 5 minus 5 plus minus 5 squared 4 4 2 times minus 5 is minus 2 minus 10 minus 5 raised to the power 2 is plus 25 minus 2 times minus 10 is plus 20 plus 25 so 24 20 plus 4 24 plus 25 will give us 49. Now remember that what we have is that 2 operation minus 5 is equal to root r, so therefore 2 operation minus 5 is equal to root r. Now where 2 operation minus 5 is equal to 49, so we put 49 here, so root r is equal to 49. That's what it implies. Okay, so next thing is for us to get r, we need to eliminate the square root sign. To do that, we need to take we need to square both sides. We need to square both sides to be able to eliminate r. So squaring both sides, squaring both sides, I'm going to have root r over 2 and 49 squared. So 2 here, r is equal to 247. So the value of r is 2401. Homophilatory to look for x plus 1 operation x over x. And we tell that x must not be equal to 0. And so we have to simplify this. Okay, so we are going to first of all, let's evaluate the numerator part. So first evaluate the numerator. First evaluate the numerator. The numerator is x plus 1 operation x. Okay, so from our rule of combination, we're given that a operation b is equal to a squared minus 2ab plus b squared. So our a is x plus 1 and our b is x. Okay, so this will give us x plus 1 squared minus x plus 1 x plus x squared. So x plus 1 squared, let's open a bracket, x plus 1 x plus 1 x times x will give us x squared, x times 1 is x, 1 times x plus 1, so x squared plus 2x plus 1, so this will give us x squared plus 2x plus 1 minus x times x is x squared. Okay, x times x is x squared plus x squared plus x squared minus plus 2x plus 1 minus x squared. That would give us minus x squared minus x plus x squared. Alright, so x squared minus x squared, okay, x squared plus x squared is 2x squared. 2x squared minus x squared plus 2x minus x and then plus 1. That will give us 2x squared minus x squared is x squared, and then plus 2x minus x will give us plus x plus 1. So, okay, x squared plus x plus 1. Remember, so let's see if we can factorize this. X squared plus x plus 1. So we're going to have two factors when multiplied by. As for the product, 1 times 1 is 1, so product is 1, and then when subtracted, when added, it gives us 1. Well, this expression can be factorized, so we should stop here. Then we'll come back to what we have is the x plus 1 operation x over x. So it's there, therefore x plus 1 operation x over x equals to the of this part, x squared plus x plus 1 over x. And this will give us x squared over x plus x over x plus 1 over x. This will cancel. This will give us x plus 1 over x. Obviously, x plus 1 over x plus 1 is our final answer. So, given that p star q is equal to p raised to the power 2, q raised to the power 2 plus pq, and p star p plus 1 is equal to 61. Find the value of p. So, in this, from the binary rule of combination, p star q, p is p, q is p plus 1. So let's first of all evaluate this part. So let's say first evaluate. Let's evaluate p. Now let's evaluate p star p plus 1. So p star p plus 1. P will anyway have p. Just put p. Q we put p plus 1 place of q. So p squared plus p plus 1 p plus 1 squared plus p plus 1 p is power 2. P plus 1 will be us plus 2 plus p plus 3 plus 2 p plus 1 plus p raised to 2 plus p. So now we have p squared, 3, p squared, and then 2p plus p plus 3p plus 1. Remember, but p star p plus 1 is equal to 61. So we need to say 3p, where p star p plus 1 is 3p squared. 3p squared plus 3p plus 1 is equal to 61. So 3p squared plus 3p plus 1 minus 61. So come over here is equal to 0. So 3p squared plus 3p plus 61 minus 61 will give us minus 60 plus 0. Dividing through by 3. Dividing through by 3. 3p squared over 3 plus 3p over 3 minus 60 over 3 plus 0, because 0 divided by 2 is still 0. So p squared plus p minus 20 plus 0 equals 0. So now we have a quadratic equation. So p squared plus p. We come here, p squared plus p minus 20. Two factors of minus 20. Or two numbers when multiplied together will give us minus 20. So multiply p squared by minus 20 will give us minus 20 p squared. So we need two factors in p. And when multiplied, it gives us minus 20 p squared, and when added, it gives us 5 plus p. So that will give us minus 4p and 5p. Minus 4p times plus 5p will give us minus 20p squared. Minus 4p plus 5p will give us plus p. So p squared minus 4p plus 5p minus 20 equals 0. P squared minus 4p and 5p minus 20 is 0. P squared minus 4p minus 4p, and then you have 5p minus 20 because it's 0. So bring out the common factor p. P into p is p minus 4, and then you have plus 5p minus 4. As you can see, 0 is p plus 5 and p minus 4 is 0. Now, so you say either p plus 5 is equal to 0 or p minus 4 is 0. So you say p is equal to minus 5 or p is equal to 4. Therefore, the values of p are minus 5 and 4. Given that a star b is equal to a over b plus b over a, and then we're given root x plus 1, root x plus 1 is star root x minus 1. It's also find the value of x. So this implies that from what we're given, a is root x plus 1, b is root x minus 1. So this gives us root x, root x plus 1 over root x minus 1 plus root x minus 1 over root x plus 1. The LCM of root x plus 1 and root x minus 1 is root x plus 1 multiplied by root x minus 1 multiplied through LCM. Root x plus 1 and root x minus 1 multiplied by root x plus 1 over root x minus 1 plus root x plus 1 root x minus 1 multiplied by root x minus 1 over root x plus 1. So these two are LCM, and this two is also the LCM. And root x plus 1 is root x plus 1 here, and x minus 1 is root x minus 1 here. So what do we discover? This will cancel this, and this will cancel this. So we're left with root x plus 1 root x plus 1 plus root x minus 1 and root x minus 1. Root x times root x will give us x. Root x plus 1 will give us root x. And 1 times root x, root x times x1 gives us root x, and 1 times root x also gives us root x. 1 times 1 is equal to 1, plus root x times root x will give us x. Then, okay, let's put this way. Then, root x times minus 1 will give us minus root x. Minus 1 times root x will give us minus root x, and minus 1 times minus 1 will give us plus 1. And this will give us x plus root x plus root x. 2 root x plus 1 plus x minus 2 root x plus 1. So let's open this bracket. Is x plus 2 root x plus 1 plus times x plus x plus times minus 2 root x equals minus 2 root x plus times plus 1 equals plus 1. So let's call it like terms. So x plus x plus 2 root x minus 2 root x, and then plus 1 plus 1. So x plus x is 2x plus 2 root x minus root x will cancel out. That will give us 0. 1 plus 1 is 2 plus 2. This will give us 2x plus 1 and 2x plus 1. So these are final answer. So the value of x, okay, not done. Let's see. Alright. The question says if root x plus 1 and if root x plus 1 star root x minus 1 is equal to 4. So the whole of this is equal to 4. That implication. So we say but 2x plus 1 is equal to 4 is equal to 4. So we say 2x plus 2 is equal to 4. So 2x is equal to 4 minus 2. 2x equal to 4 minus 2. 2x equal to 4 minus 2. 2x 4 minus 2 is equal to 2. So divide both sides by 2. X is equal to 2 over 2. 3 over 1, 3 over 1. And x is equal to 1. X is equal to 1. Two binary operations star and O plus are defined as follows. P star Q is equal to 1 over P plus 1 over Q and P O plus Q is equal to 1 over P minus 1 over Q. And then I show that P is equal to, so where P is equal to 3 over 5 and Q is equal to 1 over 2. Now evaluate A P star Q. The P star Q equal to 1 over P 3 over 5 plus 1 over 1 over 2. Remember that 1 over 3 over 5 is that in fact what you have is root 5 over 3 plus 3 over 1. The reason is from here. So the reason can arise it 1 over 3 over 5 is equal to 1. 1 divided by 3 over 5. 1 times 5 over 2. 5 times 1, 5 over 2. Same applies to 1 over 1 over 2, which is equal to 1 divided by 1 over 2. 1 times 3 over 1. Next time is division of fraction, division sign to multiplication. Then this other part of the fraction will be affected. This denominator will become the numerator, and this numerator will become the denominator. Then multiply 1 times 3, 1 times 1, 1. That's it. So 5 by 3 are LCM 3. 3 to 3 is 1, 5 plus 3 to 1 is 3 plus is 9. 9. So 9 plus 5 is equal to 14 over 3. 14 over 3 is equal to 4 over 2 over 3. That's E. P star Q. And then B. This is P star Q. P star Q over P operation Q. So first, let's evaluate P operation Q. First, evaluate. So let's write this as P star Q divided by P operation Q. So first evaluate P operation Q. Why do we need to evaluate only P operation Q first? It's because we already know P star Q from E. P star Q from E is 14 over 2. So now we need to know P operation Q, which is O plus Q. So P operation Q is equal to 1 over P, 1 over 2 over 5 minus 1 over 1 over 2. 1 over 2 over 5 is equal to 1 that's equal to 5 over 2 minus 2 over 1. LCM. Now we've done LCM here. LCM is 2, 5 minus 9. Now this will give us minus 4 over 2. So therefore P star Q over P O plus Q is equal to, remember, equal to P star Q divided by P plus Q. So P star Q is 14 over 2 divided by P O plus Q gives us minus 4 over 2. So 14 over 2 times. So this will go up and this will come down. Minus 2 over 4, 2 here, 1, 2 here, 2 here, 2 here, 7. Which is equal to minus 7 over 2. And that's minus 2 over 1 over 2.